Okay, so let's listen up here. We'll go over this review. Take this quiz. Okay? Whew. All right. Mr. Wid. All right, here we go. So, number one, right, the first thing we talked about in this unit was geometric sequences, right, and writing the formula for a geometric sequence. Now, this formula here is actually, it's not quite right. So I'm actually going to scratch this out here. I noticed this yesterday when I was helping some folks after school with tutoring. But it should be a sub n, that was right, but it should be equals a sub 1 times r to the n minus 1. It had like a sub n minus 1 there. So that was off a little bit. Okay? So, remember that r is our common ratio. That is the number that we what by every time? Multiply by every time, right? Okay, a sub 1, that is the first term, and then we'll use the first term in the common ratio to find the nth term, whatever that happens to be, okay? So in this case, letter A asks us to find the common ratio, the explicit formula, and the seventh term for each of the sequences. So you can see we have 3 blanks we got to fill in here, okay? So in this first sequence here, okay, what's our common ratio? What are we multiplying by every time? By 3, right? 4 times 3 is 12, times 3 is 36, so on and so forth. So our common ratio would be 3, okay? The explicit formula, that's going to be a sub n, right, equals, what was our first term? 4, very good, in parentheses 3 to the n minus 1 power. We're going to use n. You can use x if you really want to, but n minus 1 is what we're going to use here for this one. Okay, yeah, for the 7th term then, how are we going to find the 7th term? What do we do with this formula to find the 7th term? 7 minus 1. So yeah, we're going to put 7 in for the n. And you can even write it, so I'm going to write it this way. A sub 7, right? So I'm replacing this n with a 7. And then I'm going to say 4 parentheses 3, 7 minus 1 to the 7 minus 1 power, just like that. Okay, at this point, if you want to, you have 2 options. You can do the subtraction and say, okay, this is really just 4 parentheses 3 to the 6. Okay, now, what should be my next step for simplification here? Should I do 4 times 3, or should I do 3 to the 6th? 3 to the 6th. Okay, think PEMDAS, right? Parentheses. Well, there's nothing in the parentheses we can do. Exponents, so it should be 3 to the 6th, then times 4. Do not multiply the 4 and the 3 and then do to the 6th, right? Of course, if you want to, folks, you can just type in your calculator right away. Okay, you all get to use a calculator. So you just do 4 parentheses 3 to the 6th. Whoever's spelling that is, if you guys could quiet it down. I appreciate it. All right. 2916 is your answer. 2916. Okay, just like that. And that's our answer. Okay? All right. Letter A. Okay. For number 2 now. What's our pattern here? What are we multiplying by every time here? Negative 0.5. We're actually cutting it in half. We're dividing by a 2, but we're multiplying by negative 1/2. So, okay, negative 1/2. If you guys are ever unsure, take your second term, divide it by your first term. So negative 40 divided by 80, that simplifies to negative 1/2 when you simplify it. Okay, just take your second term, divide by your first term. That gives you your common ratio. Okay, so our explicit formula, a sub n equals, what's our first term? 80, and then yet parentheses, and then what goes in the parentheses? Negative 1/2 to the n minus 1. And we'll find the 7th term. So what do I do with that 7?
You got to do 7 minus.
Yeah, we'll do a sub 7 equals 80, negative 1/2 to the 7 minus 1. Okay, you can actually type this whole thing in your calculator if you don't even have to simplify the 7 minus 1 to get 6 there. All right, yep. You can just put like the answer if you want to, or you can just put this if you want to. You know, that's okay. I mean, yeah, it's good to show your work though, so I would encourage you to show your work, but I think here it would be okay just to put the work, or just put the answer. Now, to the 7 minus 1, make sure you put parentheses around 7 minus 1 if you're going to leave it with a subtraction like I did here, and you get 1.25. Okay? And there's our answer. Questions on any of that?
I get it now.
What, you know what the bonus means?
Yeah.
Okay, we'll talk about that. So let's look down at the next section then. So that was what we started with, right? Geometric sequences. All right, let's go down to this one. Now we also then talked about growth exponential functions and decay exponential functions, okay? So for letter B, the directions say circle whether the relationship below is exponential growth or decay. You get bonus points, and yes, you will get bonus points on the quiz if you correctly state the growth or decay factor for all 4. Okay, so that means what we're multiplying by every time. Okay, kind of like the common ratio or the b value. Okay, so in this case, right, looking at our x values and looking at our y values, is this an example of growth or decay here for number 3? Growth. Why?
Because it's going up and it's positive.
What's going up?
X.
Yeah, the x goes up and the y's go up too. Okay, now, can someone tell me what is the growth factor here? Multiply by 4. So you can just say 4 is the growth factor there. And that gives you a bonus point right there. B equals 4 is fine. You will not lose points if you get the bonus wrong. So you might as well try it, right?
One question. The growth is over 1, right?
Say again.
It's over 1, right? It's higher than 1 is growth.
Correct. Yes. If you're multiplying by something bigger than 1, it's growth. And if you're multiplying something between 0 and 1, it's decay. Okay? Let's look at number 4. All right, here's a graph now, not a table, a graph. According to this graph, are we looking at exponential growth or exponential decay?
Decay.
Decay. Why? It's going down. Now, what's our growth factor? Or what's our, sorry, a decay factor here? What's the decay factor here? What's that?
I got
5/18ths, you're saying?
What?
Okay. Well, so, right, this one's hard to see, but it was pretty easy to see when we had in a table, right? Let's go ahead and make a table, right? So this point right here has the coordinate 150. So I'll go ahead and put that in my little table here just to kind of help us out, organize things. The next point is going to be 2, and then what do you think that y value is? 25. And then what do you say about 3? That one's going to be harder to see there. Yeah, okay, so it's actually going to be, yeah, this one's hard to see. It's going to actually be 12.5. So, I mean, so it's going to be hard to see this one, but at least to go from 50 to 25, what do we multiply by? 1/2, right? So our decay factor there is 1/2. Okay.
Or divide by 2. That can work too.
It's divided by 2, right. But remember, for these, Eric, we're always talking about what we're multiplying by, what we multiply by. Okay? So you're right, though, for the pattern, but if it's the decay, it's the factors, we want to talk about that.
Okay.
All right, number 5. Growth or decay? Decay what?
I think it's growth. I got decay.
Okay, right. It's the b value here that we're multiplying by every time, right? It's got the exponent, so we keep multiplying by 0.55. What about this indicates it is a decay?
It's just 0.5.
Because it's less than 1 but greater than 0, right? Okay, and so our bonus here, though, is going to be the 0.55, the b value. Okay? Okay? Yes, call you butter. You're on a roll. All right, so number 6. Growth. Why is it growth? What is greater than 1? What number? Yeah, the b. Okay, the 5/3 here. So 5/3 is our growth factor. Okay, and it's greater than 1. I didn't circle all of those. Okay? Yeah, 1.6 repeating. Exactly right. Okay? Easy peasy, right? Hopefully that's some easy bonus points for you, too. Okay, now,
I think I'm right. But it's
letter C. Letter C. Shh, we're gonna have our function here. F of x equals 2 to the x. Okay? We're asked to graph the function to the right. Okay? We have to come up with a y-intercept, and then we also have to come up with a point, the next point here, which is just 1 comma, and we come up with the matching y value there. Okay? So, let's think about this, right? We've got to look at this here. What is my b value according to this function? 2. It's the 2, right? B is 2. What's my a value then? 0. Not a 0. It would be a 1. There's no number written in front, so we'll put a 1 there. So a is 1. That's, remember, a is my y-intercept. So I have a point there at 0, 1 right there. Okay, 0, 1 right there. Which means I can fill in this blank right here. My y-intercept is 0, 1. Okay, well, we'll get to that. Okay, but you're right. But yes, okay. So now I'm going to make a table to help me graph the rest of this graph. Okay, I'm going to put that y-coordinate, remember, in the middle. I'll do 2 points before, 2 points after. I'll go -1, -2, and then 1, 2, like that. Okay. X table. Okay. And again, it's your choice. If you want to do this with some mental math, I mean, some of these numbers here are not that hard, right? You just plug 1 in for your x. What's 2 to the first power? 2 times 1, 2. So you get 2, right? And you can do 2 to the second. 2 to the 2 is 2 to the 2 is 4 times 1 is 4. Okay? And then for the -1, again, just using your graphing calculator, if you like, you get 1/2 and you get 1/4 for the y's there matching. And we'll just plot these points. Okay? So 1, 2. Okay, oh, and look, 1, 2. That's the point there that I'm missing. 1, 2. 1, 2, right there. So I plotted it, but I also see the coordinate right there. And then 2, 4. Okay, I'll do -1, 1/2, and then -2, 1/4. Okay, and then I'll just kind of connect the dots here. Okay, like so. Is this an example of growth or decay?
Growth.
It is growth, okay? You can see it a bunch of ways here. You can look at your graph and see you're going up. You can look at your b value and see that you're greater than 1, okay? Your table also is getting bigger as your x values increase, so your choice. Okay, now, I'm going to do this other one in a different color so that way it stands out some here. Number 9 tells me transformations. We're going to take our function f here, we're going to transform it. So, yeah, Trey, what is this x plus 1 going to do? We're going to, so, but I'm sorry. I see what you're saying. So 2 to the x plus 1 like that. Okay, and then the -3 will go on the outside like that. Okay, how is this plus 1 going to transform things though, folks? What's it going to go? Yeah, Alex. Left 1, and what's the -3 going to do? Down 3. So if you want to now, okay, we can actually, actually that's what we're supposed to describe right here. So left 1, down 3. Okay, remember that the number in with the x, it does the opposite of what you'd expect. So a plus 1, you think, oh, plus 1, go to the right. It's the opposite, go to the left.
That's why I said.
Yeah, so be careful with that. Now you know, right? And then the number on the outside, that does do what you would expect. So it's going to go down 3 instead of, the opposite or anything. Okay? So now, we're going to graph this one, okay? And so you can, again, type this in your graphing calculator if you want to, or you can just take all of our points that we got right here and shift them left 1 and down 3. So, for example, this y-intercept, I'll go left 1 and down 1, 2, 3, and plot my point. And this point right here, left 1 and down 1, 2, 3, and plot my point. And this one right here, left 1 and down 1, 2, 3, and plot my point. Okay? The asymptote that's here at the x-axis also shifted. Right, there's my asymptote. That also is going to shift down 3. And so down 1, 2, 3, there's my asymptote right there. Okay, and so we'll just have something like this. Okay, and I don't know if it's going to go through the exact same points there or not, but you get the idea. Okay, so there's the other curve. Okay, the asymptote. So for our 2 to the x there, okay, you can see that our graph is going to get smaller. The red one here is going to get smaller and smaller and smaller, get closer and closer to 0, and so it's just got an asymptote of 0. Okay, but then because we shifted everything down 3, that asymptote will also shift down 3 as well. So from 0 down 3 to there. Okay, so a normal asymptote for a function that doesn't really have any transformations up or down, it's going to have its asymptote at 0. And then if you have a shift up or down, you just move it up or down with the graph, that much. Okay? All right, we also want to talk about the domain here. What's the domain of our function right here? -infinity to infinity. Okay, again, no surprises there, right? Every function we've seen so far has been that. What about the range, though? Is the range also -infinity to infinity? No. It's not 0. It's the blue one, Brady. It's the blue one. So what's our lowest y value here? -3 up to infinity. And we don't include the -3, right? Okay? So far, so good? Questions up to this point? Okay. So then letter D, okay, letter D, we have 2 more here to graph, okay? And we're going to graph them in a very similar way to what we graphed up here, okay? So again, let's identify our A and our B. What is the A in this function? 2. What's our B? 3 halves. Okay, so since A is 2, that's my y-intercept there at 2. I'll make a table. Okay, put 0, 2 in the center. Oh, we're running out of space here. I'll say 1, and then 2, and then -1 and -2. Okay, and again, we'll just type this in our calculator. Make sure you use parentheses and stuff like that. 2, 3 halves to the x. Okay, so you see I just typed in my calculator there. Okay, we'll go to the table. I'll just fill in my values. So this is like 0.8 repeating. Okay, this is 1.3 repeating. 1 is 3, and then 2 is 4.5. And it looks like I can fit 6.75 on there, so I'll go ahead and do that one too. 3, 6.75 as well. because it'll fit. Actually, barely, it won't fit, but oh well. All right. So we'll, again, just plot your points then from your table. So 0, 2, 1, 3, 2, 4.5, and then I can't quite fit the 3, 6.75. -1, -1, or 1.3, so something like that, and then -2, 0.8 repeating, okay? And so we'll just go down like this. What's our asymptote going to be for this graph? Are we shifted up or down at all? Frank? Okay.
How do you make the X an exponent?
The caret button below clear. This button right here. You see it? Okay. So, sorry. Back to my question, right? Is this graph shifted up or down at all? Do we see a transformation? Do we see a shift up or down over here? No. So where's the asymptote then? 0. Yeah, it does not move up or down. It's still at 0. So we still have an asymptote right here. If you want to draw it in using a dotted line.
We have to draw it on the quiz.
Do you have to? Only unless it asks. If you don't, that's okay. I like to have it just to kind of, be there as a boundary. Okay? All right. Questions, anything else? We're going to do number 14, and then we're going to get you started on the quiz. Any questions? Okay, 14. Last one here. All right, let's identify our A. What's the A in 14? 1/3. What's the B? 3. Okay, so my y-intercept is 1/3, so I'm going to just eyeball that, put about right there. Okay, and then I don't really like having the idea of using, well, here's what we'll do. Here's what we'll do. I'll put 0, 1/3 there. I'll put a -1 and -2. Okay, I'll put a 1 and then a 2 here. Hopefully we'll get some nicer numbers than 1/3 though. So let's type that into our calculators here. 1/3 in parentheses. Oh, no. Yeah, well. Okay, 3 to the x. That's fine. Okay. So here I get, -2. Look at that number, 0.037. All right, -1 is 0.1 repeating. 1 is 1, 2 is 3, and then I ran out of space because 3 will be 9. That's too high. Okay, plot your points. So 1, 1, 2, 3. Okay, and then -1.1, very small, and then -2.2, very small. Again, though, where's our asymptote going to be here? Let's see. Where's our asymptote? Yeah. Is that what you said, Ethan? Yeah. Y equals 0. Y equals 0. We're not shifted up or down at all, right? There's no transformation out here moving things up or down. Our asymptote is still at 0. It did not get moved, so we still have our asymptote at 0. And so we're just going to bottom out there. Okay, so there's our curve. Something like that. Okay, and voila. Okay. If you need to, of course, you can always go to your graphing calculator and take a look at it too. Right, it'll graph it for you. There it is. Okay. But use your table to get some nice actual, coordinates and stuff like that. All right. Any questions for me before we get started on this quiz? You want to do it? You're not ready for it? Okay. So yeah. So, Braden, you don't want to do it either? No. Okay. So Brady and Braden, because he was absent, and Braden since they were out too. So well, there are the quizzes. If you want to hand those out, I'm going to get going here for the rest of it. So you can take whoever, and then we'll just leave whoever in here too.